Good morning. Welcome back to your calculus, differential calculus. So last video we discussed about the derivative of a function, okay, and so with the relationship with the slope and with the of course properties of limits, and we had an examples, and we even have a zoom for the question and answer. So now let's proceed with the unit 4. This is still under your module 2. Okay. So we have here what we call as the chain rule. Okay. So we will be having additional rules which will be applied or to be added in your properties or formulas. Okay. So chain rule. So this rule applies if, okay, your y is a function of another variable, okay, instead of x, it is a function of another variable. Let's say that is u, okay? Y is a function of u, and at the same time, that u variable is a function of our variable x. So before, we have your y as a function of x directly, but now you have y as a function of another variable, and that variable is a function of x. So as you can see, since that is u, and if u is a function of x, I can substitute that, and that will still be y function of x. But, okay, according to chain rule, okay, the alternative solution for that is to, okay, if you are finding the derivative, so we are talking here of derivative of y with respect to x, or that is just y prime. So if we are having this function, okay, there is a third variable involved, then all you need to do is, in the first problem or in the first equation, differentiate with respect to the variable u, with the third variable u. And then of course, go to the second equation of our third variable, differentiate that one with respect to x. Okay, why are we differentiating your first equation with respect to u? Because that is the independent variable. It means that y depends on u. Therefore, if I will differentiate this one, that will be dy du. And then the same with your second equation, x is your independent variable because u depends on the value of that. Therefore, if I will differentiate this one, that will be du dx. Now, I will just multiply these two derivatives, then I will end up with my y prime or dy dx. Okay, how is that? Of course, just like fraction, if I will multiply, the third variable du will cancel, therefore you will end up with dy over dx. Okay, so that is your chain rule. If you have a third variable involved, okay, so that your y is not directly function of x. So let's have an example for that. Find the derivative of y equals 4u raised to 3. So as you can see, y is a function of u. At the same time, that u is a function of x, wherein u is equal to x squared plus 5x. So this is now this type of function. Okay, so that could fall under chain rule. Okay, so let's try to solve that one under chain rule. First, let's try to differentiate y with respect to u so that we will bring out that dy du. Okay, so again, with respect to u, if I will differentiate both sides, okay, differentiate both sides, you will have this derivative of y as dy du. And then, of course, if I will differentiate the right side with respect to u, that will be, okay, power rule. 3 will go down, that will multiply with 4, that will be 12. Copy u, subtract 1 with exponent, so that will be u squared. Differentiate u with respect to u, that will be du over du, or that is all over, or that is equal to 1. So I do not need to write that. Therefore, that is the dy du, which is 12u squared. Then, let's figure out the other derivative, which is the derivative of u with respect to x. So that will be your second equation. I will just differentiate this one with respect to x, since x is your independent variable. Okay, so differentiate both sides again, but this time with respect to x. So that will be du dx. On this side, I can distribute, but I do not need to do that since we already did that before. And if you are again used to this, then that will just make your equation longer. So why not do it in your minds? Okay, that let's say I distributed that one because that is some rule. Then if I will be differentiating your x squared, that will be power. So power rule, bring down 2, copy x, n minus 1 is 1, dx is 1. So I do not need to write that one. Okay. If I will go inside with 5x, okay, I will be differentiating this one. I can bring outside 5 and differentiate x. That will be dx. So again, that is 1. I do not need to write that. Therefore, the derivative of this function with respect to x is 2x plus 5. Okay. What are we trying to figure out here? Is the derivative or the y prime or dy dx. Okay. So according to my chain rule, because what I have is dy du and du dx, all I need to do is multiply. So if I will multiply these two derivatives, 12u squared and 2x plus 5, that will give me my dy dx, which is, okay, 12u squared 2x plus 5. But look at our derivative. Our derivative is y with respect to x. So your variable should be at least only y in x only. So you need to eliminate the third variable u. How will I change that one? I will just go back, of course, to the value of your u, which is x squared plus 5. Okay, that is your value of u. So I will substitute that one to the u. Then that will just become, of course, that will just become x squared plus 5x, the quantity squared. So this is now your final answer for your derivative using your chain rule. Okay, using your chain rule. You might be thinking here of multiplying, okay, that will make your equation longer. So this is the most simplified form. Most simplified form of equations are always those that are factored, okay? Those are the most simplified form. There is an OR solution or another solution. Let's say you forgot about chain rule, okay, and you have this type of function wherein you have a third variable involved, okay? There is an alternative solution for that, wherein first is that substitute before differentiating. It means make your equation in terms of y and x only, because we are after dy dx, so that I will get rid of u. Therefore, I will not worry about dy du or du dx. I will just directly differentiate with respect to x. So what will I do? If I have there the value of u, I will substitute that one, so that I will eliminate u. Okay, so that is what happened here. In your example here, okay, that is u cubed, but there is a value of u wherein that is expressed with respect to x. So I will put that one. Therefore, this is your equivalent equation, okay, from 4u cubed, that will become 4 the value of u raised to cube. Okay, so your equation or your function is now y and x variable. We do not need to worry about your third variable u. All I need to do now is just differentiate, just like what we did before in your properties. So if I will differentiate both sides, of course, this will be dy dx or y prime. You can write that one as y prime. If I will differentiate this side, okay, 4 will just go outside since that is just a constant, or that will be, you can still put it there. But just worry about this, okay, focus on this one. You have a complicated function raised to a function, I mean a power. So that is power rule. Again, just like your power rule here, just bring down, copy n minus 1 and differentiate inside. Okay, so that is what we will be doing. If I will bring down 3, that will multiply. That will make it 4. That will multiply with 4. That will make it 12. Okay, copy your function. This is your entire function because that is the function raised to 3. So just copy that lower or the function. And then subtract 1 with your exponent, which is 3. That will become 2. And do not forget, again, in power rule, you should always differentiate your function. So if I will differentiate my function, okay, you might be asking, why is that in here there is no value? Again, bring down 2, copy x, and minus 1 is 1. If I will differentiate x with respect to x, that is equal to 1. So I do not need to write that, but if you want, you can still write it and then later on simplify. But in here, okay, I do not need to write that, since that is automatically, that will not change your equation. But in this, if I will differentiate the inside, there is such a value like this. Okay, how is that? If I will differentiate inside, okay, this will be some rule. Okay, don't worry about your exponent. I already applied the power rule. All I need to do is differentiate the function inside, which is sum rule. I will differentiate this one and differentiate that one. That is your sum rule. So if I will differentiate 2x, that will be power again. So bring down 2, so that is just like here. Okay, so that will be 2x. Differentiate your 5x, that will be just like here also, which is 5. Therefore, again, power rule, bring down 3, that will multiply to make it 12. Copy your function and minus 1, and do not forget to differentiate your function. So this is your derivative. So that is your final answer, which is exactly the same as your answer here using your chain rule. Okay, so that's it. There will be times that your chain rule will be a little bit shorter compared to your alternate solution. Okay, alternative solution. But just like this one, there are also times wherein your alternative solution is shorter than your chain rule. So at least you should know about your chain rule, even if you can just differentiate that one without following your chain rule. But as simple as this, that is just chain rule. If you have a third variable, differentiate the first equation with respect to that third variable, and then differentiate the third variable with respect to x, and then multiply, you will have your dy dx or your y prime. Okay, so that is chain rule. Okay. Second rule, inverse function rule. Okay, so when will this rule be applied in differentiation or derivative is that before, if your y is a function of x, so it means y depends on value of x. But now it is the reverse, wherein x is depending now on the value of y. So x is a function of y. It means that y is the complicated equation and x is just separated on the other side. But we are still after, let's say we are still after the derivative or dy dx or y prime, okay? Let's say we are still after your dy dx, but that is your equation. It is now x as a function of y. So how will I find that one? Okay, so this is the rule of inverse function. Since x is the one separated, I will differentiate this equation with respect to y. Okay, it seems like I just exchanged the x and y. If your y is a function of x, then differentiate with respect to x. But this time, x is the function of y. Therefore, I will differentiate with respect to y. Okay, so if I will do that, I will differentiate this with respect to y. What I will be having is dx dy. But what we need is dy dx. So using your algebra of fraction, okay, if I will divide 1 with that one, that will flip. Okay, so the rule of fraction, I will divide 1 or I will reciprocate this dx dy because that is what I will be having here. Then that will go on top, so that will still be dy dx. Okay, so let's have this example. Okay, again, as you can see, x, okay, x is separated instead of y. But what we need is dy dx. So what will I do? I will just proceed differentiating with y, so that I will have this dx dy, and then later on I will just flip that one to make it your y prime or dy dx. Okay, so I will differentiate with respect to y both sides again. So this will become dx dy. Okay, don't worry about that. That will still be the same. This is some rule, and then if I will go inside y cube, that is power rule, and so it is. That's it. That is power rule. Okay, so power rule. Bring down 3y squared, okay, dy dy. Differentiate your function is dy dy. So again, that is 1. I do not need to write that one. Okay. Go with your negative 4y squared. Differentiate that with respect to y. That will again be power rule. Bring down. So that will become 8. Y and minus 1 is 1. Dy dy again, so 1. So I do not need to write that. So this is the derivative of your function with respect to y. But that is not what we need, because that is not what is being asked. What is being asked is for us to find your dy dx, okay, or y prime. So what will I do? I will make use of your inverse function rule. What I have is dx dy. I will just flip that one. Okay, if you say flip, I will just get the reciprocal of that. So if I will reciprocate this one, I will reciprocate also this one. or I will just follow your inverse function rule. Dx dy, that is the value, and that is 1 over dx dy. Therefore, can I simplify this further? I don't think so. You can factor out y, but of course that will still be the same, which is also simple. So this is now your derivative, or this is now your y prime or dy dx. We used your inverse function rule because instead of y again to be separated, it is now x which is separated. Again, an alternative solution for that. Let's say you do not want to make use of inverse function rule, or you forgot about that inverse function rule. All you need to do is the same, just like before, just proceed differentiating directly with respect to x. But okay, if you will do that, you will expect here y prime, you will expect there y prime. Okay, so let's try to do that. Differentiate directly with respect to x. If I will do that, this side of equation will be dx because that is x, so that will be 1. Okay, I need to write that because there is no partner of 1, so I need to write that to say that there is a 1 there. Now, what is this? This is again some rule, but with respect now to x. So if I will differentiate, this will go down 3y and minus 1 is 2. This time, this will not be cancelled because that will now be dy dx. It is not dx dx, or it is not dy dy. So that will be there. Or if you want, for you to be writing it as simpler, you can write it as y prime. It's up to you, especially if that is a very, very long solution. Why not make use of y prime instead of dy dx to shorten your solution? Okay, so dy dx again, power rule, bring down, copy n minus 1, differentiate y, which is dy dx because we are with respect to x. Same as this, 2, that will be 8, y, and minus 1 is 1, dy dx. Okay, it is almost the same as this, but when we differentiated this one with respect to y, so this and that is 1, so it is not present here. But since it is now with respect to x, that should be there, dy dx or y prime. Okay, now what are we after is to find out dy dx or your y prime. So what I need to do is I will bring that outside, since first term, second term, they have both dy dx. So I will bring that outside, or I can factor on that one outside, so that what will be left inside is just your 3y squared minus 8y. What I need again is dy dx, so I do not need this. Divide both sides, or what you can do is you can do cross multiplication. Why? One term, this is a single term because of that multiplication. This is just a single term, even if there is a minus there. This is considered as single because everything is multiplied. Okay, so cross multiply or divide both sides by 3y squared minus 8y, then that will be having, okay, mawawala siya dito. It will be gone in this side, then you are on left with dy dx. So I will transfer that, or let's say I will just interchange them. Dy dx is equal to 1. This will go down 3y squared minus 8y, which is exactly the same as our inverse function rule. So again, it's up to you. Okay, we are just presenting this additional rule for you to be for you to have an alternative solution if ever, let's say, your what do you call this one? Your ordinary differentiation will give you a long solution. So we will be giving you these rules for you as your alternative solution. Okay, so that is inverse function rule. Okay, higher derivatives. Okay, if you say higher derivatives, that is just repeating the process of derivatives again and again and again. So if you will differentiate for the first time, of course, first derivative, we call that one first derivative. The answer in your first derivative, differentiated again, second derivative, differentiated again, third derivative, fourth derivative, and so on and so forth. So this is how it is done. This is your function originally. Y is a function of x. If I will differentiate it, of course, let's say that will give you your y prime or dy dx. That is your first. If I will differentiate it again, okay, for the second time, that will be this form, or you can just simply write it as y double prime, y triple prime. Okay, so that is the flow. If you will differentiate, the number of prime will be adding 1, but of course, you need to be familiar with this. First, second, third, it's okay. You can just make use of your prime or apostrophe. But if you have there 4 and above, okay, this is how we will write the derivative, not in terms of prime. Because imagine if that is 15th derivative, then what are you going to do is to write down 15 apostrophe. Of course, that will be too long. Okay, that will make your equation ugly. Okay, let's say 20th derivative, then 20 apostrophe in your y. Then you have their y 20th derivative a lot of times. Of course, that will be ugly. So, if you are now having fourth derivative starting from fourth, you can now write this one just like a power. The only difference in powers that we enclose that one with a open and closed parenthesis. Okay? To dictate that power is not a power, rather it is a derivative. Okay, so that's it. So let's have an example. Okay, find the y raised to 4 open and close parenthesis. That means that is fourth derivative of this equation. So I will differentiate both sides. I do not need to be writing there d over dx, d over dx. No, since we already done that before and we are now let's say we mastered that already, why not make use of, why not do it in our minds and then just come up with the answer. Okay, just we will be doing the process in your mental, but we will just be writing the answer so that we will not be having very long solution. Differentiate both sides. Again, do not forget always both sides. Okay, let's say we did that in our mind. So if I will differentiate this, that will be of course y prime, because that will be dy dx. If I will differentiate this, okay, in our minds, if we will put there d dx, that will be some rule. So all I need to do is distribute. So if I will differentiate this one, that is power rule. So in our minds, again, we are doing that one. All we need to do now is apply the power rule, bring down, that will be 6, copy, and minus 1 is 2, dx is 1. Okay, so that is the answer for this. How about this? The same power rule, bring down, that will become 10, x, and minus 1 is 1, dx is 1. And of course, derivative of constant, which is negative 4, is 0. Okay, we are done. That is your first derivative. Okay, in higher derivatives, you need to make sure that you did the derivative in both sides. You are done with the derivative on both sides before proceeding to differentiating it again for the next derivative. Okay, so you need to make sure that you, let's say you are applying second derivative. Okay, so you need to make sure that you apply the second derivative on the left side, you apply the second derivative on the right side, so that that will be totally a second derivative before you will proceed with the third derivative. Okay, so that is what we will be doing. I already applied here my first derivative in both sides, so I am now ready to apply both sides again my second derivative. So differentiate again. Derivative of y prime will be y double prime. Okay, derivative of this is again some rule, distribute power, and that is power. Okay, so I will now be bringing this down, 12x and minus 1 is 1, dx is 1. Derivative of 10x, of course, bring out 10, dx is 1. Okay, so that is just 10. So that is your second derivative. Okay, fourth derivative, third, continue. Differentiate again, that will be y triple prime. Differentiate 12x, that will be 12. Differentiate 10, 0. And then, for the last time, differentiate this third derivative, that will be fourth derivative, differentiate 12, that will be 0. So as you can see, while we are differentiating, the degree of the equation reduces one by one. Look at this, the degree of your original equation is third degree. It means if we say degree, the highest exponent. And then since we applied a derivative, it became second degree. We applied again derivative, it became first degree. We applied again derivative, it became constant, and of course, up to the time it will be 0. So even if you will continue that one, let's say you're finding y or the 10th derivative, that will still be 0, 0, 0, 0, 0. Okay, there is no equation at all. Why? Because derivative of 0 is 0, derivative of 0 is 0. Okay, so that is example number 1. Let's have one more. Find the y double prime. Okay, y double prime, or the second derivative with respect to x of this equation. Okay, So there is no such formula as square root. There is, but I did not introduce that one because actually we can convert that one always to power, which is, of course, a little bit simplified for you. Instead of me giving another standard or properties for that, why not go to the well-known, which is power formula? Okay, so that you will not be having a lot of formulas to memorize. Okay, so before I will differentiate, why not rewrite this one into exponent? So square root again, so that is raised to 1/2. Okay. Now, if I will differentiate, that will be y prime. If I will differentiate, this is function, complicated function, but raised to a number, so that is power rule. Okay, so power rule, bring down, okay, copy the function, n minus 1. Okay, so if I will subtract, okay, if I will subtract 1 from 1/2, it will give me negative 1/2, even if you will calculate that one in your calculator, negative 1/2. And do not forget again to differentiate inside. If I will differentiate inside, 4 will be useless because the derivative of 4 is 0. Negative x squared, do not forget there's a negative there. Okay, so that will go down. So that will be negative 2x dx, or that will just be negative 2x. So again, where did this negative 2x came from? That is the derivative inside. Okay, so power rule. We are done with the first derivative. Okay, but what we are after is second derivative. So okay, this is unnecessary, but of course this will make your equation shorter. Okay, so why not simplify it first? Simplify. Let's say you are just done differentiating. Simplify before proceeding to the next differentiation, especially if your answer is long, and if you will simplify, that will make it shorter, then of course that will make it easier for us to differentiate. So why not simplify? Okay, you have there negative 2. If I will multiply here with 1/2, that will be cancelling. 2 and 2 will cancel. You are left with negative 1, and together with x, and multiply by that quantity raised to negative 1/2. So that is the first derivative. Now I will differentiate for the second time. Okay, I am done differentiating both sides. So I will proceed to the next differentiation. Both sides again. So differentiate y prime, y double prime, of course. Okay, now if I will differentiate this function, what property? Okay, what property will I use? Okay, so as you can see, x is a function, and of course this complicated here is a function. So this is a product of two functions. So this is product rule. But since there's a negative there, it's up to you. If you want to include negative as part of your first function to say that your first function is negative x, why not? But for me, okay, I'd rather, since negative stands for negative 1, I can just factor that outside. Okay, I can just bring that one outside. It's up to you. Or if you want, you can still take it as a part of your first function. So, okay, in my solution here, I took it as part of the first function. Okay, so I took it as part of the first function. So I will, what is the power rule? Copy, differentiate, plus copy, differentiate. Okay, so that's it. So that is what we'll be doing. Copy, differentiate, and then copy, differentiate. Okay. So I will first copy negative x, differentiate this complicated equation, which is power, using power. So the answer is enclosed in this bracket. Okay. Power rule, bring down negative 1/2, copy, n minus 1. Okay, negative 1/2 minus 1 will give me negative 3/2. If you don't believe me, then you can calculate using calculator. Okay, negative 3/2. Okay, and do not forget to differentiate inside. So if I will differentiate again inside, that will be 0, that will be negative 2x. So this is negative 2x. So we are done with the first part, which is copy, differentiate. Now let's go to the reverse. Plus, I will copy now this complicated and differentiate negative x. Copy the complicated, differentiate negative x. Of course, that will just be negative 1. Okay, we are done with the second derivative. All we need to do now is simplify, of course. Always simplify to the most simplified form. Okay. So look at this. Let's simplify this complicated term. This is just a single term. As you can see, okay, if I will erase the bracket, that means everything is multiplied, right? There is no plus minus since this is inside the exponent. So negative x times negative 1/2 times this quantity times negative 2x. Okay, everything is multiplied. So why not worry first about the numbers? Negative 2 times negative 1/2, it will cancel. It will make it positive, and 2 and 1/2 will become 1. So positive 1. So you are having only there x multiplied to negative x, which will give us negative x squared, and then of course copy your complicated equation. In here, okay, that is just negative 1, so that will just make the operation minus. And then of course, okay, we are now left with two terms. But you can make it still simpler by looking at the similarity and bring it outside again, factoring. Of course, minus, I can bring that outside. What else? In this first term, you have this complicated. You have that also in your second term. So look at the smallest. That is the always the one that we will be bringing or factoring outside. So if I will ask you, what is the smallest from negative 3/2 to negative 1/2? 3/2 is a bigger number but negative. So of course, the bigger the negative, that is the smaller number. So this is the smallest. So that is what I will bring out together with my negative. There is no x, so I cannot factor there any x. I can only factor negative and the smallest, which is the function raised to negative 3/2. Okay, what will be left inside? Do not forget to put that one in a bracket so that you will not be confused. Because if you will not put a bracket there, it means that this is a single term, two terms. So we just made our solution wrong. That is what you will be doing. So if you factored, always enclose what is left. Okay. So if I will enclose what's left, what will be left here? I brought outside negative. I brought outside this complicated one. What will be left is just positive x squared. In here, okay, I brought outside negative, so that will make this plus. And I brought outside a negative 3/2. Okay, a negative 3/2. So again, we are factoring. So if you bring outside 1 with exponent, what will you do? Subtract the exponent. Okay, so again, originally that is negative 1/2. Subtract whatever you brought outside, which is negative 3/2. Negative negative will make it plus, therefore that will just become 3/2 minus 1/2. The same, 3 minus 1, 2, that is fraction. That will be 2/2, or that is 1. Okay? So that's how we ended up here with exponent, which is 1. Okay? Did you understand that again? Originally, we have their negative 1/2. But we factored out negative 3/2. Therefore, I will subtract negative 3/2. If I will be subtracting a negative, that will make it plus. So, if I will combine that one, if you do not believe me about this, you can calculate that one. But you should believe me. You should know how to prove this one. You are an engineering student, okay? So, that is a fraction. So, that's it. Then, if I will do that, then look at this. There is no use of me putting this grouping sign, which is the parenthesis. I can take that away. There is no effect in the signs because that is plus, okay? So x plus 4 minus x squared. Therefore, x squared and x squared will cancel because that is minus and that is plus. So you are just left with, okay, in this complicated function inside, that will just be 4, which will be going here as negative 4 together with that negative all over this. And then again, as I told you in our previous examples, this exponent is a negative. So cross the bar. It means transfer that one across the bar. If that is on top, put that one below. If that is below, put that one on top. Okay. So that is what will I do. I will put that one below, so that will make it positive. But again, for me, I do not want a fraction exponent. So I will put always a fraction in terms of radical or in terms of roots. So as you can see, where's my pointer? Okay, so you can see 3/2. It means 3 there is exponent and half, or the denominator of your exponent is your root. That is the meaning of that. That's why in this one, the square root is 1/2 because the exponent of the one inside is 1 and the root is 2. Therefore, that is square root. Here, it means the exponent of inside is cube and 2 there is the root, which is the square root. Okay, so that is now your final answer, this one. Okay, or if you do not want to put that in radical, why not still put it as fraction, but of course make it as positive. So I will transfer still below. So that is higher derivatives. Okay, so we will just be repeating differentiation again and again and again and again to how many times it is required. So higher derivatives. Okay. Okay, one more topic. Yun. Implicit differentiation. Okay, final na to na rule. Actually, this is not a rule. This is a technique. Okay, actually those chain rule, inverse function rule are also techniques. Okay, why? Because we got those. Even if you do not know this chain rule, inverse function rule, if you still be applying your formulas, you can still end up with dy dx or y prime, isn't it? That's why we have their alternative solution. Okay, implicit differentiation, the same. Okay, when will this be applicable? Okay, by the way, before we will go there, let's try to define what is implicit function. Implicit function are functions with no variables expressed explicitly. Okay, if we say no variables is expressed explicitly, example of that is this one. Okay, look at this equation. X is not separated, and so with y is not separated. Okay, so this is what we call implicit function, because before x is or y is a function of x, that is, we call that one explicit because y is separated. Okay, or in your inverse function, if you have the inverse function, you have x is a function of y, it means x is separated, so that is still explicit. Now if they are mixed together, okay, no variable is separated alone, then we call this one implicit function. And how are we going to find out the derivative or y prime of that? Just the same. Just proceed differentiating both sides with respect to x. Since, of course, what you're after is dy dx or y prime. But if your problem requires you what is dx dy, then differentiate with respect to y. So it's up to you. Okay? So differentiate both sides with respect to x directly. Okay? Okay, so look at this. Find the second derivative. So we are on higher derivative, at the same time your function is explicit. Implicit. There is no separated. So x squared plus y squared equals 4. Okay. So I will differentiate. It says there just differentiate. Yes, just differentiate with respect to x, because what we need is y prime or y double prime. It means dy dx. So if I will differentiate both sides, that will be power, and that will be 0. Okay, so bring down to x, dx dx. Okay, so 1. 2y, dy dx. Of course, there will be y prime there. Do not say that that will cancel. No, because that will be dy dx. Okay, you should know it by now. Okay, why is it that there is no dx dx here again? Because that is equivalent to 1. Why is it that there is y prime there? That is dy dx, because we are differentiating with respect to x. Okay, now this is the original solution for that. Let me show you another alternative, but the same. The only difference is how we will proceed to the next differentiation. Okay, so what will I do is simplify first. Bring out first y prime before proceeding to the next. Before, in your higher derivatives, in my example a while ago in the last slide, I just proceeded because y prime is separated there on the other side. So I will differentiate again. But this time, as you can see, y prime is not separated. It is there in between, or in between your equation, long equation. So what will I do? I will separate first. So I need to separate y prime. I will put 2x on the other side. That will make it negative 2x. So we are left here with 2y y prime. I do not need here 2y. So divide both sides by 2y. Then what will be left is y prime. If I will divide this one by 2y, negative, I mean 2 and 2 will cancel. You are left with negative x over y. So this is the most simplified of your first derivative. That is your first derivative. That is not what we are after. What we are after is the second derivative. Okay? So we are done with the first. I can now proceed. I already separated that y prime. So we can now proceed. Okay, so if I will differentiate again, that will be y double prime. But in this one, that is quotient rule. Okay, so it's up to you. You can put negative with your y below, or you can put negative with your x on top. Or if I were you, it is better if I will factor out negative outside. I will just put that one outside. I will worry that one later on. Okay. So what will I focus? I will focus myself on x over y. I will differentiate that. That is quotient rule. We're in quotient rule. Copy your law. Differentiate up, which is dx. That will be, I do not need to write that one here. Again, low, d high. I will differentiate the high, that is dx or 1. Minus high, the low. Okay, so high is x, copy x. Differentiate low, which is y, that will be dy dx. That's why that is y prime. All over low squared is y squared. Okay. We are done differentiating. All we need to do is simplify. We are after a second derivative. So in your equation, you should only have there the type of derivative. Let's say equation wants you to solve the fifth derivative. Then you should only have their fifth derivative. There should be no other types of derivative, only fifth derivative. So since in our problem, the unknown is the second derivative, then what should be there in our final answer is just the second derivative. Okay? It's okay, sana. However, you will see there a y prime. So, what will I do? I need to get rid of y prime. I will go there on top. Since y prime is there, I will substitute that one. So that is what happened. I substituted the value of of y prime. So if I will substitute, all I need to do is simplify, okay? Multiply, negative, negative will become positive. X will multiply on top, x squared. Okay, there are a lot of fractions. I should only have there a single bar. Okay, that is the most simplified form of fractions. There should be a single bar only, or a single fraction. What will I do? I will combine this. Okay, look how we will do it. You might forgot your basic fraction or your basic mathematics. Okay, so you have here your, okay, let me put it here so that you can see. Y minus x times, okay, let's say that's already multiplied. So plus x squared over y squared. I need to get rid of that because this is the main bar. That should be the one left only. So what will I do? I will combine this one. I need to make this fraction so that I can combine with, okay, let's say that is raised to 1. That will be the same, okay? Then that will be, hey, there's a negative. Do not forget there is a negative there in your answer. What is the LCD? Isn't it? That is our rule. LCD, what will be the least common denominator? Is y. Y divided by 1 is y times y will be y squared. Of course, nothing happens there. X squared. Y squared. So what will happen there? A fraction. This is the main bar, so that will go down. Y times y squared will make it y cubed. Then you can interchange that because x goes first before y. So x squared plus y squared. Okay, so that is how your answer here is done. Okay, here. But as you can see, it's okay. This could be your final answer. But if you will go back to the problem, x squared plus y squared is just equal to 4. Okay, so since that is the equivalent of x squared y squared, I can substitute that one. Then that will be negative 4 all over y cubed. That is the final answer. Okay. So that's it for implicit. Just proceed differentiating and then bring out whatever is required. Okay, this is my another solution, but the same, of course, differentiate both sides with respect to x directly, but the difference here is that here, in this solution, what I did is I will first separate to y prime before I will differentiate. So that is what I did here. But you can actually do it directly. We do not need to bring out yet y prime. Okay, so let's say I will differentiate again, and this is of course the differential. But of course, for me to be having a simpler solution, isn't it? I can factor out 2, or I can divide both sides by 2 so that 2 will be gone. So even if there is a 0 divided by 2, that will still be 0. So that you will have now simpler equation, there is no constant 2. Or you can do is factor out 2, cross multiply it below, so that will still be the same. Okay, now I do not need to separate first y prime. Don't worry about this. We will be just doing this later on. I will just differentiate. So differentiate x, that will be dx, so 1. Differentiate y and y prime. Okay, don't say that these are single. No, they are different functions. X and y prime are different. I mean variables. So take it as product. So copy your y, differentiate y prime, that will make it y double prime. Plus, copy y prime, differentiate y, that will make it again another y prime. Okay, you can now combine these two, that will make it y prime, the quantity is squared. So this will be still y prime. Okay, I can get rid of the grouping because there is no use of that. Okay, so now all I need to do is separate my y double prime because that is what I need. So I do not need 1 and y prime squared. I will put that one, both of them, so they will become negative. So we will be having y and y double prime here only. I do not need y, so I will divide both sides by y. I will be left with y prime only. And on the other side, okay, look here, that is just the same as in this part. So of course, we only need y prime, so we have the y prime. Go back to this equation, get your y prime, substitute it again, and the same simplification a while ago, just like here, you will end up with y negative 4 over y cubed. So any question? Implicit differentiation. Okay, so please practice again. And by the way, we have a try this in your own activity. Again, please do it. Your exam will be starting on 16, which is next week, Wednesday. Okay, your exam is already approaching. So your exam is already approaching, so please practice. We will be having a sit work, a quiz before the exam. So maybe this will be the cut off of my discussion. Will that be? Or okay, maybe I will be adding more, but this is the main focus. Because our next now is an application. That is now already an application. Start of your application. So that we will start the application before we will go to finals. It means we will continue the application on finals. Okay? So, please try this in your own. You will be having an answer. So this is, as you can see, we are trying to find y prime or dy dx, or first derivative. And this equation is implicit function. So implicit differentiation. You should have this answer, or you should have that one. Okay, the only difference of this is that I factored out here negative 1. So if I will factor out negative 1, what will be left inside is your x minus y, and there's a negative 1 outside. It's the same with below. There's a negative 1 outside, and negative 1 cancel, so the same as this. Oh, the same as that. Please try this in your own as a question on tomorrow. We will be having we will be solving this one next meeting. At the same time, we'll be asking question. At the same time, the remaining time, we will be having a short quiz. short quiz. Okay, we will be having a short quiz. So please, again, if we say quiz, your webcam should be working because that is the only way for me to monitor if you are doing it in your own. And as much as possible, you, of course, you really need to connect, because if you cannot join our meeting, our online meeting, then you will not be having that quiz. Okay, so that will be tomorrow, which is Saturday. You should find a place wherein there is an internet connection. Okay, do not give me a lot of reasons that you cannot access, because that is the reason why you enrolled online. It means that at least you have there maybe a source of net for you to, of course, join our classes. So please try before 10 o'clock, because your schedule is 10 o'clock. Before 10 o'clock, you should be there on the site where you have there an internet access. I will be giving you the link of the Zoom. So before 10 starts, you should be there already entering in the link, so that all I need to do is accept you. Okay? And then we will discuss this one, and then we will be having a short quiz. Again, of course, quiz, you need to prepare long bond papers. And of course, you need to prepare yourselves by reviewing. Okay? So, if you have any question, you can comment it right now below your video, so that I can answer that one right away. Okay, thank you very much for listening.